Hello. I thought I'd outline a method of doing two-sided milling on a 3-axis milling machine. There was a question posted on 3D CAD jewellery forum, so I just thought I'd do a little video and hopefully it'll help out. Now I don't know what milling machine you're using, information was a bit sparse on the post, so I'm just going to go through a really basic setup, and then obviously if you've got a more sophisticated mill, then you won't need to use some of these things. But how I'd start about it, I'd make a plate up on the milling machine, sort of like this, dimensions, you can work out for yourself what suits you best, but bear in mind it's only to machine rings, it don't have to be massive. Now you could do this out of aluminium, which would be ideal, but also you could use plastic or even a worktop, plastic worktop, chopping board, or corian if you could get hold of it. It's nice to work in as well. Small pieces sometimes come up on eBay and whatever. Anyway, so you need to be making something like this. There's a hole right in the middle of it, and you've got a couple of countersunk holes there, and then these are shown as blind holes. You don't have to be, they could be through holes, it's just how I made the model. And then that is bolted with two countersunk bolts. The bolts have obviously got to be lower than the surface of the metal, down to the table. Now you'd obviously have to work out your own fittings for this. I don't know what type of table it is on mine. It's just screws, threaded holes, so you could just measure them and screw them straight down, but it might be T-nuts and you'd have to come up with a way of holding it. And then these are two interference fitted pegs, so they're just tightly fitted in. Again, it could be best probably out of tool steel if you can get it, or just normal steel. I suppose you could use, well, anyway, that's what you need, two pegs. So that's bolted down to the table, and then what we're going to do with that is fit a big block of wax on it, like so. Now obviously because you've got the pegs, it's not going to fit on so I've also made another piece of steel or plastic or whatever with the two holes that correspond with the two red pegs in. Now you could put this on top of the wax and just drill through with a hand drill, or halfway or full way, whatever. So this will keep the drill square, and it's only wax you just be able to drill in, and that'll allow you then to fit this onto that, and those two pegs of sufficient diameter will be enough to hold it for all intents and purposes. Now once you've done that, you need to write a little program that surfaces the top of this wax, so it surfaces it and also drills two holes in it. I've got it's got a hole there, but ignore that. But so it's basically surface that to the same level as the bed, and then drill the two holes, but the actual holes are opposites to where the pegs are. So you've got a peg there, but you need the hole line that, so when you flip it over, obviously they'll align properly. So let's swap back to that one. Okay, so we've got our wax top, but before we can begin surfacing it or anything like that, we need to work out where our zeros are, because with this method the 0 points are an absolute dead important thing. So basically the way I'd go about this, again I don't know, is turn the wax off. We've got the plate there. Now if you get the milling machine and jog the spindle to pretty close to this, say about 5 milli above it, and as close to the centre of that hole as you can get it, with your eye. And then if you in the chuck, you have either an upside down 1/8 tool, so the actual shank of the tool sticking out of the chuck, or if you can get a piece of 1/8 tool steel or metal bar, that's ideal. And this is an 1/8 hole that's drilled into here, so get that as close as you can, and then you can jog it, or you can actually turn the mill off, and move the spindles with your fingers, move the bore screws or the leech screws with your fingers until you can get that, so you can slide it, because it's slightly loose in the spindle, you can slide it in and out of that, and once you can do that, it goes in there without forcing it. You can zero your X and your Y, which are there. So that's basically putting your X and your Y in. Now when you bolt this to your table, another thing to sort of bear in mind is try and get these sides running level with your X and your Y. So basically, if you jog down with your metal bar in and touch there, jog away and jog there, that number should be the same, you know, on your Y. So you'd say you're touching that and it's, I don't know, -10 or something. Jog away, jog down to that gently, just really slowly. And then when that's just touching that or just above it and you can drop down, it should be -10, and that indicates, you know, your y-axis is square. It's not critical, but if you get everything square, your mill must be really square as well. Then you'll get better results, because what you've got to remember is that anything that you have out on the model will be doubled when you turn it upside down. So that's why it's important to get square. Right. So then we need to set the Z axis, which is the height. So again with the metal bar in, and actually you're probably better putting the tool you're going to use in it. So jog it up out the way, put your tool in it, jog it down to an area here. Again, 4 or 5 millimeter away. Slacken the spindle off slightly, and then pull the bit out so it touches the top. Don't force it, just be gentle so it touches the top. Nip the spindle up, tighten the spindle up then, and then jog away. Well actually, when you've touched it, sorry, zero the Z axis first, so then jog up out of the way so it's safe out of the way. So that's given you, basically it's put the Z there and the X and the Y there. Now this is where it gets a bit complicated. When we've got our wax block on like that, we want to be using this middle of the wax block. So when we set our tool, our program in Rhino, we want the ring or whatever you're making, you want the world origin right in the centre of it, in the X and the Y dimensions. And then we get, say our wax block needs to be 30mm, so that's 15mm. So halfway is 15mm. I mean, I don't know what size it is, but it doesn't matter. So halfway on the Z is 15mm. So if we turn that off, that there is 15mm from there to there. So if we then jog, okay. So what you need to do, I don't know where we're up to, but let's start again. So you found Z0 now with your bit touching there. What you need to do now is jog this up to 15. Now on the Z axis the minus numbers go down, plus numbers go up. So jog up to 15. When it's at 15mm, what you need to do is zero your Z axis. So that'll give you something like this. Your X and your Y there, and your Z is zeroed 15mm above the table. Okay, so we'll go back to our wax block now. Let's turn the other half on. So we're working on that this wax block's 30mm, so the actual wax block that you put on wants to be about 33mm. And the reason for that is you need to face the top of this, so you need to run a tool path so it mills away all the top of this so it's perfectly flat. So it's all flat. Okay, so that way when you turn it over we know exactly where this line is, because it'll ignore anything and cut down, but if it's skew width, when you turn it over it won't see it properly, so it'll throw it out. So you need then to face the top of this and drill your 2 holes as we said before. So write a little program in the tool path to do that. Now once that's done, we're all set up, we can run the program then. So I'll leave that on for now. So if we put that there, get rid of that. So halfway, that's your ring there. Now you won't be able to do inside there, but it's just the ring that I had that thrown on. But it'll come. Okay, so the cutter basically will come down then, and cut like that. Now this circle is your boundary that you let it have in the tool pathing program, and what I always try and do is, if you're roughing with an 1/8 milling bit, then always draw an 1/8 circle here and make sure you've got an 1/8 gap on the biggest part, so it can always get round it to clean it out. And it will cut down, say it's cut to exactly halfway there, so you'll be left well with that if you take that away, just so you can yeah, so that's what you'll be left with in the wax. And then simply, he says, okay, so if you then let that run its course, I'm just debating whether I do a finishing pass at that, but no, I don't think you can do. You could do it after and just swap it back. So then what we need to do, if we select that lot, get that point there, and then twizzle that round. Make sure when you do it in your software that make sure that you turn it the same way as you do on your software. If it's around, a symmetrical ring, it don't matter, but if it's not, it'll cut it the wrong side out. So make sure you flip it the same way as you flip it on your software, looking. So if you sort of say, right, I'll flip it around the x-axis, then do that on the software and do it in real life as well. Okay. And that's it then. It'll run and cut, and then it's you'll cut down to this, and then you'll have your ring all nice and sorted. Just cut the supports out, but again, if you're doing this on it doesn't matter, it's 4th axis. So yeah, I hope that makes sense. If not, just let us know and I'll try and go over it again. Alright, thank you for watching. Bye bye.